Okay, so hopefully I'll just go through, for example, question 5 of question 2. So you end up with something like 2, 6, 3, 9, 2, 3, negative 4, and then add 5 lots of negative 1, 2, 1, 3, negative 6 and 2, and then you take away 4 lots of negative 2, 4, negative 2, 1, 3, and negative 1, okay? So, nice and straightforward, nice and straightforward. First things first, just multiply through, okay? So tidy this matrix up. So you're going to multiply every single element by 2. So you end up with 12, 6, 18, 4, 6, and negative 8, okay? Multiply every element in here by 5, so you get negative 5, 10, 5, 15, negative 30, and 10. Then you take away 4 lots of everything in here, so 4 lots of negative 2, which is negative 8, 4 lots of 4, 16, etc., negative 8, 4, 12, and negative 4, okay? And then you just simply add together and subtract the corresponding elements. So 12 plus negative 5, take away negative 8. So 12 plus negative 5 is 7, and then take away negative 8, it's 15. Careful with double negative, right? So it's going to be 15. Okay. And then 6 plus 10, 16. Take away 16 is 0. Good. 18 plus 5 is
23.
23. Take away negative 8.
31.
31. Perfect. 4 plus 15. Take away 4. 15 again. 6 plus negative 30.
24.
Negative 24. Take away 12.
36.
Negative 36. Cool. Negative 8 plus 10. 2. Take away negative 4. 6. Make sense? Nice and straightforward? Yeah? So addition, subtraction of matrices, multiplication of scalars, numbers, that's fine. That's fine. Okay? You notice the only condition here is that all the matrices have to be the same size, obviously, because you need to add or subtract the corresponding elements. So if you had an extra column here, for example, there's no extra column in either of those two matrices, so you don't know what to do with them. Is that okay? Good, fantastic. Okay, we'll come back to question 3. I'll get you to do question 3 in just a second. Is this all okay, though? There's no questions about this. York, is this okay?
Yeah.
Okay, good. So can we have a look at question 4? So question 4 asks to take 4, 3, 2, 10 and multiply it by 2, 5, 6, negative 1. Okay. So, first things first, you could just jump ahead, if you're confident enough, and find the product of these two matrices. Okay? However, I would advise to do it how we did it over there. So I'd advise to set something like this up. Okay? Before we do that, though, we need to check whether we can actually multiply the two matrices together. So what are the dimensions of this matrix?
2 and 2.
2 by 2. What are the dimensions of this matrix? Yeah, same, 2 by 2. So therefore, if we're multiplying these things together, okay, because we're multiplying them together, can we do this multiplication? Can we do this product? Yeah, because the inner two dimensions match, okay? What are the dimensions of the resulting matrix, do we expect? 2 by 2. So like I say, set it up how I advised you to set it up before. So set up something like this, okay? Put the first matrix down here. Put the first matrix down here. This is the first matrix, put it down here. 4, 3, 2, and 10. Put the second matrix up here. So let's just copy it down. 2, 6, 5, negative 1. You notice you copy it exactly. So this looks exactly the same as this. This looks exactly the same as this. So on the top you've got 2 and 6. On the bottom you've got 5 and negative 1 in that order. Then you find the product. And to find the product, you just simply look there. You say, okay, that's that row and that column, and multiply the corresponding elements together. So 4 times 2 plus 3 times 5. What's that?
Yeah.
Yep, 24. 23, sorry, yep, because it's 8 plus 15. Okay. 4 times 6 plus 3 times negative 1.
24, negative 1, 21. 24, negative 3, so
21,
21.
perfect. 2 times 2 plus 10 times 5.
4 plus 54, 54.
And then 2 times 6 plus 10 times negative 1.
12, negative 2.
Okay, so the resulting matrix should be exactly the same as that. 23, 21, 54, and 2. Can I ask you to have a go at the rest of question 4 for me?